Hey, everybody, happy Monday. We are going to finish up this chapter pretty soon. We've just got one more topic that is spheres that we'll be doing today. And then we'll just get you guys ready for the test that'll be later this week, probably on Thursday. So here we go spheres. A sphere, of course, looks like a ball. You've seen spheres all over the place. We're going to look at basketballs and bowling balls and all kinds of stuff today. And here's the good news. Save the best for last. We only have two formulas. There is no lateral area for a sphere because there is no base. So the total surface area is, well, the total area. It's if you painted a sphere, if you had a bowling ball and you wanted to paint it or something like that, I don't think you should do that, but that's what surface area is. There is no base, and so it's just simply 4 pi r squared. If you were memorizing this, I'd recommend that you just remember that it's 4 times the area of a circle. But since you don't have to memorize this, you'll have access to a note card. You don't have to worry about that. And then the volume formula is this one, 4/3 pi r cubed. Again, a little bit more complicated, but you've got a note card. You can use your notes on the tests and quizzes, so no worries about that one. Um, there it is, 4/3 pi r cubed. Don't be scared, that's a fraction, but you've got a calculator. You can do 4 divided by 3 very easily on your calculator. So here we go. That's all we need to get to the problems. First one, the radius of the moon is about 1,080 miles. It's not a perfect sphere, but it's pretty round. So if I say, what is the area of the surface of the moon? Using a couple words there as clues, what is the area of the surface? I'm looking at the surface area. So surface area formula is 4 pi r squared. Plug in the radius was given as 1,080, so plug that in for the radius. And then I'm just plugging it in a calculator, 1,080 squared times 4. And so if I want an exact answer, that would be it. Looks like 4,665,600 pi miles squared. But for a problem like this one, exact answer probably doesn't make sense. We'll go with 14,600,000 miles squared as the surface area of the moon. So there we go. Kind of big, scary numbers, but the math wasn't too bad as long as you've got a calculator. Second question. Um, the surface area is 196 pi centimeters squared, and I want the radius, diameter, circumference, and volume. Well, I guess we're working backwards right away with cones and prisms and pyramids. We did one day forwards and one day backwards, but since spheres aren't that complicated, we can go straight to backwards. Same as we did for previous stuff. If the surface area is 196, of course, we'll go with the surface area formula, 196 pi, and plug that in for the surface area. And right away, there's only one thing that we're missing, and that is the radius. So divide both sides by 4 to get rid of the 4 on the right side. I could have divided by pi first. I chose to divide by 4 first, but it doesn't matter. Divide by pi, or if you want to just divide by 4 pi, you can do that, but be careful how you type that into your calculator. And then finally, since the radius squared is 49, then the radius is 7. So 1 down, 3 to go. But now that I know that the radius is 7, diameter is just twice as much, so that's 14. Circumference of a circle is same as circumference of a sphere. Circumference is pi times diameter. So since we already found the diameter, that was 14 pi. It said the exact, so I kept that as 14 pi. If you want to plug that in your calculator and get an approximation, you could do that also. And then finally, the volume. Here we go for the first time with this formula, 4/3 pi r cubed. But the only thing that I need is the radius, and I found that up here. So plug in 7 for the radius, and then everything else is on your calculator. 7 cubed times 4 is 1,372. This is the exact answer. If you wanted an approximation, you could go with 1,436.8 cubic centimeters, but I asked for the exact, so that would be the answer that I would go with. All right, moving along, the next one, I've got a basketball problem. I looked up the regulation size of a basketball. Whoops, sorry about that. And that is 29.5 inches in circumference for a NBA basketball. So if I say find the amount of air needed to fill an NBA basketball, am I talking about surface area or volume? And hopefully you're talking to yourself right now as you're watching this video. Yes, it is the volume. The volume is what we need to fill it up. And so if I know what the circumference is, I'll go to my circumference formula. Circumference is 29.5, so I plug that in for the circumference. And then to solve for the unknown, I don't go straight to the volume, but I'll be able to get there with the radius. So I use this equation to solve for the diameter, just divide both sides by pi. When I did that on a calculator, I got the diameter was about 9.39 inches. Uh-oh, these should be in inches. Sorry about that. If the diameter is 9.39, I divided that by 2 to find the radius. The radius is 4.695. Sorry, I'm talking and writing at the same time. And then finally, if I want the volume of a basketball, I've got a formula. The volume is 4/3 pi r cubed, and 4/3 times pi times the radius, 4.695 cubed. I got 433.5 inches cubed. When you plug this in your calculator, I would recommend doing 4.695 to the third power first. There should be a button on your calculator where you can do the third power. And if you can't find that, then go with, there's probably a caret button that gives you this symbol, and do to the third power, and that'll take care of that. If you're not sure, let me know and I can hopefully help you figure out how to do that on your calculator. But then multiply by 4/3 times pi, and I got 433.5. All right, moving right along. Here is a bowling ball question. The bowling ball has this much material. So again, are we talking about volume or surface area? Probably not surface area, since that's what this question is asking for. The amount of material, that's definitely the volume. So I go with the volume formula. Volume is 4/3 pi r cubed. We're given 322 inches cubed, so I plug that in place of volume. And then the rest of this is just algebra. I multiplied. To get rid of the 4/3, I multiplied by 3/4. Dividing by a fraction is the same as multiplying by the reciprocal. And so to undo multiplying by 4 and dividing by 3, I multiply by 3 and divide by 4. So that's where the 241.5 came from. And then I divided both sides by pi to get to 76.87. And then finally, for this part, it's not squared, it's cubed. So instead of taking the square root, I had to do the cube root. And again, hopefully there's a button on your calculator. Those of you with TI calculators, go with the math button. And when you press the math button, the cube root is the fourth option down. If you're doing this on your phone, as I'm suspecting many of you are, there should be a button that looks something like this would be my guess, something like the cube root of x. And if you don't have something like that, if you're using a caret, you can also do something to the 1/3 power. So raise it to the 1/3 power. Just don't forget to use parentheses when you do that. Anyway, however you do that on your calculator, the cube root of r cubed is r. The cube root of 76.87 is about 4.25, about 4¼ inches. And then finally, we're in the clear because I've got a formula. The surface area is 4 pi r squared. I just found out that the radius was 4.25, so I plugged that in place of the radius. And when I plug this in my calculator, I got about 227.2 square inches for the surface area. And then finally, one last problem for us today, the concrete part of a storage silo. So that's one of these big, tall things you see if you drive by a farm. Farmers use these to store things and not take up a whole lot of land area on their farm. You can have a whole bunch of, well, we used to keep silage in the silo that the farm that I grew up on, but you could put, I suppose, lots of different stuff in there. Anyway, the storage silo that we're looking at in particular is 100 feet tall, and the diameter is 20 feet. And then on the top of it, there's a hemisphere. Hemisphere, I'm sure you've heard that word before. That is just half of a sphere. And I want to know, what is the total volume? So first, I'm going to find the volume of the cylinder, and then we'll find the volume of the hemisphere by taking a whole sphere and then just lopping off just taking half of that. So for the cylinder, I know that the height was 100 and the diameter is 20. That means the radius is 10. There's our formula for the volume of a cylinder, pi r squared times h. 10 is the radius, 100 is the height, and we'll plug that in to get about 31,415.9 cubic feet. And then finally, the hemisphere on the top of this thing, I did 1/2 times the formula we have for volume. So 1/2 times 4/3 pi r cubed. And all you got to do is plug in 10 for the radius. And so half of 4/3 times pi times 10 times 10 times 10 to get 4,094.4 cubic feet. And then finally, I just added the two. I got this for the volume of the cylinder and that for the volume of the hemisphere, for a total volume of about 33,500 cubic feet. So there we go. As I mentioned, we'll have review tomorrow so we can hopefully get ready for the test I'm planning on Thursday, either Thursday or Friday, but I think because of what the governor said last week, I don't know if we've got school on Friday, or maybe we'll see what happens. But I would plan on Thursday, and we'll see if that ends up sticking with Thursday. But that is my plan for now. That's the end of that chapter. So we are done with volume. So let's just make sure we do well on that test. If you haven't already, get all these formulas in one spot. That's going to help you out a lot on the test. All right, that's it. Good luck. See you next time. Bye.